Greetings and welcome, friends! We're taking a look at last night's quest, page 497. We were talking about graphing polynomials through approximation, I guess. We talked about the idea of kind of local max and min. The extrema was the plural word for the extreme values, right? And this particular problem, question 1, it says, state the greatest number of relative minima that are possible for each condition. Let's see, here we go. So let me draw a picture of each of these, and then we'll actually talk about the number of minima. Let's see, I think I'll just do one of these, one of these, one of these. Man, look how awesome this is so far. This is amazing. Amazing graphing pictorial abilities here right now. Good stuff. So it says a third-degree polynomial with a positive leading coefficient could look something like this. All right, bam, you might remember the end behavior. A third-degree polynomial with a negative leading coefficient, right? Just kind of flipperoo, right? Generally, they could look like this. They don't necessarily have to have that many bends, but they could. Fourth degree with a positive, that would be your classic W case. What? And then fourth degree negative leading coefficient is your upside down W, more commonly known as an M. So let's count the minimums here. The relative minima in this graph is 1. Relative minima in this graph is 1. In this graph is 2. In this graph is 1.
But they don't get that part. Why?
Because I'm only counting the valleys, the minima, the low points.
Oh, so valleys minima is now in his maxima?
You got it. Nissan Maxima. So if I wanted the maximas, they're there, and there, right? So that's what they would have been. But they were just interested in the minima, so it was 1, 1, 2, and 1. Right? So interesting little analysis, definitely worth knowing the general shape of these based off of their degree and their leading coefficient. Let's see, here's problem 12. Looking at 12, it says, state whether each graph is of odd degree or even degree. State the number of relative minima and relative maxima. So let's see. Now, you could possibly try to count it based on the number of bends and say, well, this is a fourth degree function because its degree is going to be 1 more than the number of bends. But that's not 100% guaranteed. The way to truly determine the degree of it is to just look at the end behavior. So the fact that this is opening in the same direction in both cases tells me that it's an even degree. In fact, I could gather even further information. The fact that both of them are pointing up tells me that the leading coefficient is positive. Leading coefficient is positivo, right, is positive. So they didn't ask about that fact, but I just want to point that out that we would know that. I would expect that this could be a classic fourth degree, but it's not necessarily going to be that. It could be a sixth degree with just maybe only 3 actual bends or something like that as well. So if I want to calculate the minima and maxima of this graph, well, the maximum appears to be 1, just occurring right there, right? 1 maximum. And the minimum, it appears to have 2 little valleys hanging out there and there. So that's what they were looking for in that problem, something to that effect.
So,
question, yes?
if, like, one of the end behaviors is pointing down, would it be an odd?
You got it. Odd degree functions have end behavior that points in opposite directions. Good question. Good question. So let's take a look at question 15. For 15, they were specifically only interested in approximating zeros to the nearest tenth. I might end up analyzing this a little bit beyond that. So what I gave you last night was a little spreadsheet that you had access to on Google Docs.
And it didn't make sense.
Okay. Well, let's start counting by ones and start at -4. And let's plug this in. So this is 0x to the 5th. There is no x to the 4th term. There's a 1x cubed, a minus 2x squared. There is no linear term, and then there's a 6 for the constant. So here's my setup. So let's analyze this chart, and then we'll zoom in on it if we have to. Yeah, I'll just go between there and there. Should be good. Should be good. Good, good, good. Here we are. So analyzing this graph, or chart rather, let's figure out zeros, or x-intercepts, right? Same difference. Zeros. So when do zeros occur in a chart? When the sign changes for our y coordinate. So notice that looking at it, negative, 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 positive, it went from negative to positive, so a 0 must have occurred somewhere between those 2 points. So I locate zeros by analyzing the y coordinates. I define zeros by using the x coordinates. So I'm going to say a 0 occurs from negative 2 is less than x is less than negative 1. So somewhere in there, a 0 occurs. Now looking at the rest of this, positive, 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 and in fact I expect that this is going to go positive forever here, and this is going to go negative forever there. Because it's an odd degree positive leading coefficient, so it comes in from the negative, goes out the positive, is what's going to happen there. Now, let's actually zoom in between negative 2 and negative 1. Going back to my Excel spreadsheet, let's have it actually start at negative 2 maybe, maybe even negative 3. And let's count by 0.1. Well, I'll start at negative 2.
I don't like that part, but just do a random increment all the time. Is it good back in how it's going to get?
Well, on the test or the quiz, you'll have the table already constructed for you, and then you'll just analyze it, is the idea. So here I've zoomed in. So basically, this little green arrow here, or bracket, I guess, has now become this whole thing, right? So imagine I just like zoomed in from there to there, right? Right. And now I'm looking at specifically between negative 2 and negative 1. And looking at these, where do you think the 0 occurs? Right, look, negative, 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 positive, right here. Aha, it went from negative to positive. So somewhere between negative 1.4 and negative 1.3 is the more accurate analysis. And they asked us to actually, the directions said, approximate the real zeros of the function to the nearest tenth. So we could have approximated, I would have actually said negative 1.3 is a better guess than negative 1.4.
That's what it said.
Did it? Oh, excellent. And analyzing this, why do you think I would choose 1.3 rather than 1.4? I heard multiple students say it. Yep, 0.4 is closer to 0 than negative 0.6. So I'm guessing that my 0 is likely closer to negative 1.3 than it is to negative 1.4. So my 0, I would say, is about, x is about negative 1.3 if I wanted to the nearest tenth. Technically, I could zoom in even further. Just for funsies, let's do this. Let's do this. So from negative 1.4, let's count by 0.01s. What? And look, I could zoom in even more and analyze it. It looks like it happens somewhere around negative 1.34. Well, actually, no, maybe 1.35. Yeah. Oh, no, 1.34. This is way closer to 0 than that is. So yeah, around negative 1.34 is where my 0 is likely to occur there. Now, even though this problem did not ask us to, let's see if we can analyze where the max and mins occur, if any.
Is that going to be on the test?
Yep. So let's look for the extrema. So minima and maxima. Now question, how many could this have had? Well, let's see. It's an odd degree, positive leading. The general shape of it is probably something like this. It appears that it only had 1 0, I suspect. So it probably crossed either like there or up here. All right, is likely the case before any potential bend. So it would have as many as one maxima and one minima, right? Maxima, minima, right there, bam, bam. So let's see if we can find out where it might occur. And when we analyze this, we're interested in the change in direction, not the change in sign. So let's see, negative 90 to negative 39 is increasing. Negative 39 to 10 is increasing. Negative 10 to 3, that's an increase. I don't know if you know that. 3 to 6, that sounds like an increase. 6 to 5,
Uh-oh, downcrease.
decrease. So that means somewhere from these values, let's see, from negative 1 to positive 1, it appears to have hit a value. Is this a maximum, local max, or local min, do you suspect?
Min.
Why do you conclude that?
Because it goes down and goes back up.
Well, look, it went from 3 to 6 to 5. So it went up and then down. So my maximum must occur somewhere between, or a local max occurs between negative 1 is less than x is less than 1. Notice it takes 3 numbers to narrow down the window of a maxima. It only took 2 values between negative 2 and negative 1 to locate a 0. Because in order to determine if the direction changes, I actually needed 3 numbers to verify that. So let's keep looking at this. So then it went down to 5. And then what? It went back up to 6. Crazy sauce. Guys, what? That means between 0 and 2, right? It went from 6 down to 5 up to 6. That must have been my minimum. Why do I know that that's a minimum? Because it decreased and then increased, right? Going down and then up, that's a valley. Going up and then down, that's a mountain. So between 0 is less than x is less than 2 is where my minimum occurs. Somewhere like that. Now, let me actually open up my graphing software. They didn't require this. Whoa! Here we are, friends. Let's actually throw a little graph together of this, because that is a concept on the quiz, whether or not we can graph using some approximation. Let's actually maybe even make a rectangular grid. That sounds good to me. Grid-delicious. Hi, Jacob. So between negative 4 and positive 4 is where I go. Let's see, what are my y values? Well, I'm not going to go all the way down to negative 90. Maybe I'll just go up to like 15-ish and negative 15. That sounds pretty good. So let's, I'm going to grab a snapshot of this, and I'll try to draw a picture for us based on our approximations. Our approximation? Yeah. Here we are. So let's see. Where did I say the 0 occurred? Somewhere between negative 1.4 and negative 1.3. So here's negative 1. There's negative 2. So negative 1.5 is here. So 1.4, 1.3 is like really right there. So I would say that it probably occurred somewhere around there. Let me actually choose a darker green. There we go. There we go. Bam. Right? So it only had one x-intercept. The other I didn't know about. I know a minimum occurs between 0 and 2. A minimum occurs between 0 and 2. I could zoom in to kind of narrow that down a bit. How low should it go? Well, between 0 and 2, the lowest I see it being is like 5. So somewhere around 5 would make sense for this minimum value. You might say minimum value, why is it above the x-axis? Well, it's a local min, so it's coming down to 5, something like that. Chances are it might be even a little less than 5. So something like there is my local min. Actually, let me erase my little parameter right there. And then for the maxima is occurring between negative 1 and 1. So somewhere between here and here, a maximum occurs. And how high should that maximum go? I think it was 6-ish, right? It went from 3 to 6 to 5. So somewhere around 6-ish, around 0. So somewhere like here-ish is my maximum. So if I draw this, well, I know it's coming up this way, right? It passes through there. It peaks somewhere around here. Oh, that was really sad looking. Yeah, I can see that. Its minimum value is there, and then it's going to trail off infinitely that way, as well as down that way. So let's actually graph this officially and see how close we are. Ooh, that'll be interesting. Who's better, man or machine? Haha. Here we are, 6. What? Oh, look at that. Would you look at it? Would you look at it? Wow, that's not bad.
Yeah, it's kind of like the minimum value is weird, not as out as.
So, yeah, so that's what I want to point out. The minimum value occurred between those numbers. I said it occurred between 0 and 2. I happen to pick the midpoint-ish for mine, and that's what I could have zoomed in a bit with my chart to really kind of found exactly where it occurs. But that's, pretty good graph based off of some, rough little chart that I had, right? Not too shabby, friends. So thanks for watching, Internet friends. Have a great day. Bye-bye.